So clearly I'm not the only one, right? Um, so Microsoft had messed up, right? They had put in a new whiteboard. I'm sure y'all heard me complain about it before we went on break. And it was awful. It was so bad. Like it would lag. I would write something on the tablet and it would take like 10 seconds for it to show up on the board. And I thought, I can't do it. I just can't do it. And I went searching yesterday, and it turned out that so many people were complaining about it that all I had to do is update my computer and it reverted me back to the old one. So I'm so happy to have my old whiteboard back. Um, Today we are talking about solving quadratics. Let's just call it completing the square. By completing the square. The cool thing about completing a square is that much like the quadratic formula, it works for every single kind of quadratic equation, right? Completing the square. It's actually where we came up with the quadratic formula. And later this week, when we actually do the quadratic formula, if we have time, I will explain to you where the quadratic formula came from and how it came from completing the square. I'm sure you won't be interested in it, but I think it's kind of neat, so we'll probably do it anyways. Um, Ultimately, with completing the square, we're doing what we've been doing all along, which is searching for solutions to these quadratic equations, these equations that have been written in that form: ax squared plus bx plus c, right? Where we have an x squared term, we have an x term, and then we have a constant with nothing, right? And we could have any piece of this. Like it could be just ax squared is considered a quadratic. Ax squared plus bx would still be a quadratic. Ax squared plus c, still a quadratic, because what makes it a quadratic is that its highest degree right here is a square, right? It's that 2 above the x, and that's what makes it a quadratic. Before this, we were dealing with things that were linear, right? Which meant straight lines. And so we would have like this part, right? But we wouldn't have this x squared. Notice with linear, there's no power written, right? And when we have no power, it's just a straight line. When we've got a power written, such as x squared, it's no longer linear. It's no longer making just a straight line. And so that's what we want to talk about. So when we're completing the square, before we actually get into it, what we're trying to do is create perfect square trinomials, right? So we're trying to create perfect square trinomials. A trinomial has three nomials, right? Ultimately, like if I have ax squared plus bx plus c, each one of these, each piece is considered a nomial. It is a trinomial because here we have 1, 2, and 3, right? A perfect square trinomial is when we have something that's like x squared plus 14x plus 49, right? What a perfect square trinomial is if I have a perfect square here, and x squared is a perfect square, right? It's x times x. And I have a perfect square on this end, right? 49 is a perfect square. X squared is a perfect square. 49 is 7 times 7. And I multiply the square root of this times the square root of this times 2, I would get this center term. So this square root of this is 7 times x is 7x times 2 is 14x. Do I need to know all of that? It would be nice, but it's not necessary, right? Because you're going to be working with you're going to be creating perfect square trinomials, so you don't really need to recognize them so much because you're actually making them. The purpose of this is if I have a perfect square trinomial where I have those needs met, I can break down my factor as the square root of this first part, which is x, plus or minus, depending on the sign here, the square root of the last part. So 49, the square root of 49 is 7, and it equals x plus 7 squared. Now, could I figure that out on my own? Absolutely. Like before we would take the 49 and we'd find all the factors of 49, like 1 times 49. And I don't know what else there are, but I know that there's 7 times 7. And if I add 7 and 7, it gives me my B term. And we could do all that work, but we really don't have to when we have a perfect square trinomial. What it does is it allows us to factor it really easy, right? Sort of like with the difference of squares. When we recognize the difference of squares, we could just go, okay, we could take the square root of that first piece minus the square root of the second piece, and then we could take the square root of the first piece plus the square root of the second piece. So what we're doing to complete the square is we're creating perfect square trinomials so that we can find solutions to these quadratics. So if I took this original problem that I just gave you, this little sample problem to show you what a perfect square trinomial is, and I rewrote it and I said I had x squared plus 14x plus 49 equals 4, right? Well, we know by it being a perfect square trinomial that we could break it down as x plus 7 squared equals 4. And then we can just take the square root of both sides to solve it, right? When I take the square root of something that's squared, I'm just left with what's in this parentheses. So I have x plus 7 equals the square root of 4, which we know to be plus or minus 2, right? Because 2 times 2 equals 4. And so I just have to figure out what this x is. I have to undo what's being done to x so I know what x is equal to. So I'm going to subtract 7 from both sides. I'm going to get two solutions, right? I get minus 7 plus 2, and I get minus 7 minus 2. Right? Minus 7 plus 2 is going to give me negative 5. Minus 7 minus 2 is going to give me negative 9. These are my two things that x is equal to. Here's the $1 million question. Does anybody remember what the solutions to a quadratic represent? I'll start calling on people on this one, but if you get it right, I'll give you extra credit points. No. That's a good answer. It was honest. Nobody remembers what the solutions represent in a quadratic? It's that week off, right? Just broke you all. So our solutions to any quadratic, what they represent is where that graph is crossing the x-axis. So if this is the x-axis and this is the y-axis, right? That relates to our points, right? It's the like if I have a point, negative 2, 4, this tells me the value at x, and this tells me the value at y, and I go, okay, negative 2 here, and then I have point up at 1, 2, 3, 4, and I know I would have a point right here, right? X and y values. What our solutions to quadratics are those points where we cross the x-axis, right? So these points right here are the solutions that we find. So in this case, we are crossing the x-axis at negative 5 and negative 9. We call them solutions roots, zeros, intercepts. There's a lot of names they go by, right? But that's ultimately what we're looking for anytime we're solving a quadratic, are those points where the graph of the equation is crossing the x-axis. And notice our y value on these points is 0, right? Because we're not going up or down at all. We're right on the line. So those points are y value equals 0. So a lot of times when we're trying to solve quadratics, we have things set equal to 0. So that being said, that little tangent of trying to remind you what those were, we'll move on from, because we need to get into the completing the square portion of this. I am going to start by writing the steps down for completing the square, because I think that it is helpful to have steps to refer back to. They might not make sense while I write them down, but once you see them working, that'll be a little different, right? So, step number 1, you are going to rewrite, if necessary, in the form ax squared plus bx equals c. All it means is if we have something that's not attached to an x squared or an x, we're going to move it to the other side of the equal sign, right? Because the whole idea is that we're going to create perfect squares. 2, we are going to divide both sides by a term. This is also if necessary, right? If a is something other than 1, we have to divide this by a, and this by a, right? Everything will have to be divided by a. If it's 1, we don't have to do that, because if I divide something by 1, everything stays the same, right? So if there's nothing, if I have something written as x squared plus, say, 3x equals 2, there's nothing in front of that a. There's no a listed. It means that a is 1. We don't have to divide then. But if this was 2, I'd have to divide this by 2, this by 2, and this by 2. Right? But we'll see that in action as we go. 3, we're going to do the completing the square part. Right? Complete the square by taking half of b term let's go squaring it and add to both sides. Now, that is complex to just look at and understand, but we will show you in a minute. Add to both sides. 4 factor the perfect square trinomial. This creates our perfect square trinomial. Now we're going to factor our perfect square trinomial. And I know none of these make sense right now, but they will, I hope. Man, those dogs are loud today. Can you guys hear the dogs barking through there? It'll make for a really interesting video. Then we're going to take the square root of both sides. And 6, simplify, solve and simplify. More often than not, this is going to create two answers, right? Two solutions, which makes sense when you think about it, because what are we talking about? We're talking about points where it's crossing the x-axis. Occasionally, you'll only get one. We talked about before when we had, say, the vertex right on the x-axis, we might get one, right? But more often than not, we're going to have 2 points for solutions. One is because we're taking a square root, right? And we're going to get a plus and a minus out of that. So let's just look at it. Let's do some problems so that you can see them. I think more often than not, one of the best ways to learn is by examples. And so we are going to start with some easier ones and move on to some hard ones. I want to make sure you have some examples of some of the hardest ones you might have to do, as well as some of the easier ones you might have to do. So we're going to start with x squared minus 18x plus 56 equals 0. So the first thing that we need to do is we need to rewrite it so that that constant term, that term without a variable on it, is on the other side of the equal sign, right? I have x squared and I have minus 18x. We need this piece moved over to the other side. And we're just going to subtract 56 from both sides so that we have x squared minus 18x. I'm going to leave a little space in there and you'll see why. Equals negative 56, right? It also says, our next step says that we're supposed to divide both sides by the a term, but our a is just 1. So we don't need to actually physically do that step because it doesn't change anything. If I divide x squared by 1, I'm left with x squared. If I divide negative 18x by 1, I'm still left with negative 18x. If I divide negative 56 by 1, I still have negative 56. And we will do some examples where you actually have to do that dividing out, but in this case, we don't have to, right? So our next step, it says that we are going to complete the square by taking half of our b term, squaring it, and adding it to both sides. So they're saying take b, divide it by 2, and square it. Our b is always this coefficient, the number that's in front of our x value, not our x squared value, our x value, right? So in this case, we have negative 18 as our b. The x is not part of the b. It's the coefficient in front of the x. And we are going to divide that by 2. So we have negative 18 divided by 2, and in the end, we're going to square that. What is negative 18 divided by 2? I put that one in there so that you could all get it right. Come on now. You're almost right, Jamila. What are you missing? Negative 18 divided by 2? Yeah, just forgot the negative. So here we've got negative 9 squared. But in a way, Jamila's right. It doesn't matter in this circumstance because what's going to happen now is I'm going to square it. And negative 9 times negative 9 is still a positive. So it wouldn't matter if we would have forgotten the negative on that in the long run, right? We'd still wind up with the same answer, right? It would still be 81. So it says that we are supposed to find that number and we're supposed to add it to both sides. That is why I left this little gap right here. So here I could put in the 81 and here I can add 81. So I've added 81 to both sides. What I've done is I've created here, in here, a perfect square trinomial, right? Which I know now I can write as the square root of x squared minus, because this is minus, the square root of 81, which is 9. And then we could just write that as a square. Equals, well, minus 56 plus 81, or 81 minus 56, just gives me 25, which is quite convenient because that is also a perfect square. So bam, we've done the completing the square part. We have factored it now, right? That's what we did right here. This was the factoring part. And now we have to take the square root of both sides to solve it. Right? I have a perfect square here, I have a perfect square here. So that's super convenient that everything is a perfect square. This is going to leave me with x minus 9 equals plus or minus the square root of 25, which for us is just 5. Now I'm almost there, but I haven't fully solved it because I don't know what x equals yet, because x still has that negative 9 attached to it. So we're going to move that over to figure out what x itself equals, right? This is going to give me x equals, and what we have here is we have 9 plus 5, and we have 9 minus 5, right? So we have 14, and we have 4. So my solutions here, x equals 14, or x equals 4. They are both true. They are both necessary. You should get 2 solutions. Now, I hope that makes sense. The good news is that's not the only example I'm going to do for you. I'm going to do multiple examples for you because I'm cool like that. That's right. That's exactly why. So I'm going to do one more kind of simpler one like this, and then I'm going to move into some more difficult ones. But let's do one where we actually have to divide by the a term. So if I start with 2x squared minus 16x equals negative 30. I don't have to move anything over. It's already in that right form that I need it to be, right? I've got my x terms over here. My constant is on the other side of the equal sign. I don't have to rewrite the problem based on that. I do, however, have something other than just an x squared here. So I'm going to have to start by dividing everything by this 2. Each piece needs to be divided. Right? So here we've got x squared, right? Negative 16x divided by 2 is negative 8x equals negative 30 divided by 2, which is negative 15, right? So now we're in that form that we wanted it to be in. We've done the first 2 steps. We rewrote it. Well, we didn't have to rewrite it because it was in the form we wanted. And we've divided both sides by a so that it's in the right form. Now we have to do the part where we complete the square by taking half of b, right? We're going to take whatever our b is, divide it by 2, and then square it, right? So our b now is negative 8. It's whatever's in front of x. So we're going to say, okay, we've got negative 8 divided by 2. We're going to square that. Negative 8 divided by 4, well, that's negative 4 squared, which is just 16, right? Negative 4 times negative 4 is 16. So here we are going to add 16 here, and we're going to add 16 here. And the whole purpose is we created a perfect square trinomial. We know we don't even have to think about it. We know we made it. So we could take the square root of x minus the square root of 16, which is 4, and square that. And say that that is going to equal 16 minus 15 is just 1. Again, convenient. We got perfect squares everywhere. And we're going to take the square root of this side and the square root of this side, and we're going to get x minus 4 equals plus or minus the square root of 1, which is just 1. We aren't there yet because we got to figure out what x equals, not what x minus 4 equals. So we're just going to add 4 to both sides. Here I'm going to get x equals, I have 4 plus 1, and I have 4 minus 1, right? So we're going to get 5 and 3. Those are our two solutions. Is it starting to make a little sense? Is it vibing a little bit? I know it's step heavy. All right. Let's amp it up some and find a little bit more complicated problem. I want to make sure you have samples of every kind of problem that you might get in your homework so that you can always refer back to the video if you don't remember how to do it. Oh, do I like that one? I think I like this one because it's got a little bit of everything in it. So let's try this. If I have 3x squared plus 10x plus 8 equals 0. All right. Our first step is going to be to rewrite it so that only our x terms are on this side, right? And which means I have to move this 8 over. So I'm going to go ahead and I'm going to subtract 8 from both sides so that I get 3x squared plus 10x equals negative 8, right? Now when I look at this problem, I go, okay, well, what I have in front of that x isn't a 1, which means I have to divide everything by that a term. And it's going to leave me with fractions. This is going to be the ugliest, probably hardest problem you might have to do in your homework. So I think it's a really good one to use as an example problem so that you have an example of something that's difficult, right? So the first thing we need to do is we need to divide everything by 3. Right? This cancels. I'm just ready for the x squared, right? 3x squared divided by 3 is just x squared. And then I have plus 10 thirds x equals negative 8 thirds. I can't do much with that, right? But it is going to play out the same way every single one of them is played out now. We've got it all set up, right? We've done the part, where are my instructions? So we've done the part where we rewrote it. Then we divided everything by a. Now we have to take half of our b term, square it, and add it to both sides. Now this is where you guys are going to mess it up because we're talking about fractions here, and you guys are terrible with fractions. Not any of you personally, but most students that I get are terrible with fractions. They panic when they see them, and it's not your fault. It really isn't. We just didn't spend enough time teaching them to you when you were younger. And so now you have little panic attacks every time you see a fraction. So here our b is 10 over 3. And then we have to divide that by 2 and square it. This is the part that's going to make all of you panic because this is ultimately saying we've got 10 thirds divided by 2, right? Which is essentially 2 over 1. Do you remember how to divide a fraction by a fraction? It's like my $1 million question for the day right there. How do you divide a fraction by a fraction? You actually multiply, right? This can be solved very easily by going, I have 10 thirds, right? The top part, times what we call the reciprocal. So we flip this over of the bottom part, right? Multiplying fractions is easy because once you do that, you just multiply straight across. So you have 10 over 3 times 2, which is 6. Can I leave it like that? Heck no. That's an even number over an even number. Divide each of them by 2. So you get 5/3, right? And that is what we get here, right? We wind up with 5/3 squared. Now, when we're squaring a fraction, it's easy because you just square both parts. So 5 squared is 25 over 3 squared, which is 9. Right, so once you get to that part, it's easy because you square each part of the fraction, right? You square the top and the bottom. But getting there is kind of hard. But if you look at what we just did here with this fraction, it wasn't that hard. When we saw that we had 10/3 divided by 2, that's like saying 10/3 divided by 2 over 1. It means all I have to do is turn it into a multiplication problem, and it becomes really easy to deal with, right? Did everybody follow this part? I know y'all have panic attacks with fractions, so I want to just make sure on that. Okay. So this 25/9 is what we're adding to both sides, right? I'm going to do it in a different color so that you can see that it's the thing that I'm adding in. 25/9 plus 25/9. Here's why I said this one's super ugly, because I'm going to have to find a common denominator here. But for right now, let's just deal with our factoring right here. Here we're going to have x plus, well, whatever the square root of 25/9 is. But we don't even have to look for that because we know we already have it right here, right? So it's going to be x plus 5/3 squared equals. But here we're going to have to find a common denominator. The only time you need a common denominator ever in math is when you're adding and subtracting fractions. But if you see here, I have minus 8 over 3 plus 25/9. And lucky for us, this common denominator presents itself pretty well because 3 times 3 equals 9, which means I can just multiply this one times 3 over 3. Why would I multiply the whole thing times 3 over 3? Why would I multiply the top and the bottom by 3? Does anybody know the answer to that? Let me try and rephrase the question. What does 3 over 3 equal? 1, right? Well, what happens when I multiply something by 1? What do I get if I multiply 10 times 1? Exactly. What happens if I multiply 270x by 1? Exactly. Whenever we multiply 1 by 1, we're not changing the value of anything, right? So when we're doing common denominators, we don't want to change the value of that fraction. We just want to put it together differently so that we can add and subtract them. So when I multiply by 3 over 3, I'm essentially multiplying the whole thing by 1, and I'm not changing its value. I'm just changing the way it looks. And so here, I'm going to be left with negative 24 over 9 plus 25 over 9. And I can do the math over here on the side, right? Where I'm left with 25 minus 24 is just 1/9. So this whole thing equals 1/9. So once I've done all that, like I said, this is going to be the ugliest problem that you'll see. You might have one that's this difficult on your homework, but beyond that, the rest of them will be a little bit more simple. And so now we're going to take the square root of both sides, and we're going to get x plus 5/3 equals plus or minus One thing to remember about square roots of fractions, they can be rewritten as the square root of 1 over the square root of 9. So it would be plus or minus 1/3. Am I good there? No, I'm almost good. I just need to move this minus 5/3 over, right, to get our solutions. The good news is we have a common denominator already. We don't have to find one. But ultimately, what we have is 1/3 minus 5/3, and we have minus 1/3 minus 5/3, right? So if I look at this one, 1/3 minus 5/3, I get minus 4/3. If I look at this one, I get minus 6/3, which is just -2. So those are my two solutions. That will be the hardest problem that you get, something like that. I know there is one in there on your homework. I was going to assign you the entire worksheet, but then I thought, I won't do that to you. Just coming back, and I believe I only assigned the odd problems. And I think it's out of like 10 to 12 problems. So you don't have more than 5 or 6 problems to do for your homework. But please practice them, because you don't know what questions to ask until you play with it a little bit and try. So please do the homework. It is a worksheet. It is getting submitted to PowerSchool. Make sure you show your work. A lot of people are turning stuff in with just answers, and I really can't count that. So make sure and get the work done. Submit to PowerSchool. Let me know if you have any trouble. I have my last period today. I have a tutoring time on Thursday, my last 2 periods. So periods 7 and 8, I have tutoring. Use the tutoring if you feel like you need the help. All right. Ask the questions. I can't help you if you don't ask me the questions. Speaking of which, we have 1 minute left. If anybody has any questions, if not, please feel free to go and enjoy the rest of your day. I'm sorry I took up your whole class period. Bye, Hazel. Thank you. Bye, you guys.
Bye. Have a nice day.
Let me know, Jamila, if you need a little help with that. Just let me know. Maybe we can clear it up with some of the problems. Have a good one. Bye, Nikki. Lacey, are you still there? Did I put you to sleep, or did you have a question?